Hey everyone, this is Trace here with Number Engine and the Optimization Solver add-on for Google Sheets. This video is intended to serve as a quick start guide, like a tutorial for any of our new users that have just downloaded the add-on and are unfamiliar with how to use the add-on or any of its features. And so to do that today, I'm just going to be walking you through a really quick example of a how to solve a simple problem with the add-on. And so the problem we're going to be looking at here is a pretty simple and pretty common problem that you'll find discussed in linear programming. This is what we're going to call just the tables and chairs problem. At its simplest, it's just designed to model a simple factory that makes two products from some single resource, which is just wood. So in this case, we're going to assume, hey, this factory has 400 pieces of wood. The decision that the factory must make is essentially how many tables or how many chairs or the combination of both should it make to optimize the factory's profits. Because you can see the way this decision tree is kind of laid out. Um, if the factory were to make one table, that would require 20 pieces of wood in 15 hours, but the sale price of that table is going to be $85. Whereas um, for the chair, that's going to take 5 pieces of wood and 10 hours, but you'd only get $45. So the idea here is we can model this problem in an Excel spreadsheet just like this, and the calculations will reflect the behavior and outcomes of all of those decisions accordingly. So I have this all populated here in this basic model. And just to describe to you what's going on here, let's first take a look at this legend. So in the green cell, we've got our objective function, and our objective function in this case is basically just whatever we want to do. It's what we want to optimize. And so in this case, the label we have here is profit. Hey, the factory wants to maximize its profit. So that's the objective function, and it's just modeled by a formula that we've set up here that takes into account basically the number of each product that's built, added up and multiplied with the sales price. So that's the objective function. The decision variables are basically just the decisions that are to be made in the model. And in this case, going back looking, hey, our decision is whether we just want to make a table or a chair or what combination of each. So in that case, this is just simply represented with these two cells here. The amount of chairs that the model will decide to build or the amount of tables or both, just whatever it chooses. These yellow cells are going to be used as potential constraints, and those will be linked up to what we've got in this constraints section here too. So we're going to keep track of the amount of wood that's used and also the amount of hours that are used in producing each of these items and say the total amount of resources that we have. We have 400 pieces of wood, and hey, we only have the ability to work for 450 hours. So going through these specifications for each of those items, we can say, like we had just mentioned there, the chair takes 10 hours and 5 pieces of wood, and then the table takes 15 hours and 20 pieces of wood. So let's get right into Number Engine and the solver add-on here. So just go right up to your extensions menu after you've downloaded and installed the add-on from the Google Workspace Marketplace. Then you'll get in here, see the menu from the ribbon and the extensions menu right here, and then just highlight over it, and then you'll see two options there. You'll see either launch app or visit our website. So I'm going to click launch app here, and then it's just going to open up this sidebar that's going to let you work in the UI and enter in any of your specifications to solve your models. So very simply, we're just going to start from the top down and just follow each of the instructions and fill in each of the fields that the UI requires here. So here for our objective function cell, we're instructed to put a cell reference. So hey, we're just going to type in the cell reference of this objective function cell that we talked about here. So with that, that would be C13. So C13. And if you notice, there was some red whenever I just had C in there. So all of these cells, all of these input fields have validation to tell you if your input will cause an error or not. just based on if you have it typed in an invalid cell reference or something like that. So I put like that, it's going to stay red. But C13 was a valid reference, so we're good. Okay, and then moving on here to our decision variables, we're actually going to check this box here for integers and just hovering over this tooltip. The simple explanation of what this means for the solution is that it's going to solve these decision variables as whole numbers, not decimals. Because in this case, we're going to say that it doesn't make sense for the factory to build half of a chair. So we're going to say that the factory has to build whole numbers worth of products. So that's all we're saying here. And then we can, for these decision variables here, we're just going to go C16, enter in a range and say C16 to C17. So C16 to C17. But I do want to point out that you also could write this as the following. You could do these separately, like C16 or C17. So that would work either way. Just make sure you have these both specified as an integer. And if you make a mistake, of course, you can just delete whatever with the delete button there. But we'll put that back. Whoops. Okay. And then finally, working through here to the bottom with our constraints, we're going to leave this checkbox also on by default because all that this means right here, enforce decision variable non-negativity, that may sound scary, but all that really means is that we're going to say that these decision variables cannot be negative. So the model is not allowed to solve these decision variables where it says, hey, we actually built negative 10 chairs, because that doesn't make any sense. In the real world, we would only be making positive values of products. So that's all that means for this box. And so with that out of the way, the only thing left to take care of here are the material and time constraints. And we can also do that pretty simply with the range style reference as well here. So what we're going to do is say we got C14 to C15. Put that in there. C14 to C15. And say that those cells respectively must be less than or equal to, and then we're going to say C9 to C10. And the reason we're saying that is because that's the upper limit of the amount of wood that we have. We can't use more than 400 pieces of wood, and then we can't use more than 450 hours. So that's going to be the upper limit there. And since this is a very simple linear problem, we're just going to leave this solution method here at linear. So now that we have all the pieces of our model filled out, that's how you use the UI. That's how you go through there. And just for example's sake, if you wanted to add another constraint, just like decision variables, you would use the plus button there, add more. But that's all we need. So all you got to do now is click solve. We'll wait for the model to solve. And boom, we found a solution. The model solved at 24 chairs and 14 tables built, giving us a profit of $2,270. And you can see and validate your model results pretty easily by observing your constraints and how close they got to the limits that you supplied. So that's kind of usually a good gut check for me to see if the optimization makes sense. And in this case, we actually used every piece of wood in every hour that we had available to us. So that really does tell you that, yeah, this is the optimal solution here. So that is our solution in our models. So that concludes the video. Thank you for watching. And yeah, that is how to use the Number Engines optimization solver add-on for Google Sheets. Thank you.